2 class. I hope you're doing well. This is Mr. Ryan again, now on Thursday, April 16th, and we're on 13.5, describing data, and the book starts on page 584. Now, the first thing we do is define what a mean is, and a mean is simply an average. So I think you've all understood average. So the mean is an average obtained by dividing the sum of the data by the number of values. So you simply add them all up. That's my summation of I equals 1 to n of xi. Add all the numbers up and then divide by how many. That's the mean. And that little U symbol with the leg on the left is the Greek letter mu, and that's traditionally used in statistics, which that's one of the main choices of your 12th grade elective classes is statistics, either Chattanooga State or Bryan. So you'll be seeing this a lot more next year. Now the median is defined as there's a middle number, one that you can go to if there's a total odd number of values, or the two middle numbers, you average them if there's an even number of values, and we'll give you examples for that. Then the mode is defined as the number or numbers that occur most frequently. So you can have one mode or two mode tie, or you could even have three, but we're just generally going to deal with one. So example 1, find the mean, median, and mode for the set of numbers 6, 7, 9, 5, 10, 9, 9, 6, 8, 9. So on first, to do a median, a middle, or a mode, you obviously have to sort them. So notice my little check marks above the original top set of numbers. That was me checking them as I sorted them on the line below. So first there was a 5, then a 6 at the beginning, a 6 near the end, then a 7, the second one, an 8 near the end, and then a bunch of 9. So there's 1 9, 2 9s together, and 9 the last, so 4 9s and a 10. So my sorted set of numbers is 5, 6, 6, 7, 8, 4 9s, and a 10. So the mean is to simply add them all up and divide by 10. So 5 plus 2 times 6 plus 7 plus 8 plus 4 times 9 plus 10 equals 78, and 78 divided by 10 is 7.8. Now the median, as we said, if there's an even number of values, I go to a halfway point in between the 5th and the 6th. So you see the 5th number in order is 8. The 6th number in order is 9, so I have to average between the 5th and the 6th to make an intermediate, artificial halfway point to have 5 numbers below and 5 numbers above. So that median with an even number of values is 8 plus 9 over 2, or 8.5. A number that doesn't really exist, but allows it to be the middle. Now this next thing is about doing a mode, and if we look, it's obvious that there's 4 9s, so the mode equals 9, and it's repeated 4 times. Now notice that the mean 7.8, the median 8.5 are pretty close together, which they usually are. Now this next table is doing what's called the standard deviation. So let's see what's going on with this. In our first column, remember we still had the mean of 7.8. So in our x sub I column, we list the numbers from high to low here, 10, 4 9s, 8, 7, 2, 6, 5. And then we do x sub I minus mu, or each of those numbers minus 7.8. And so 10 minus 7.8 is 2.2. The 4 9s minus 7.8 is 1.2. The 8 minus 7.8, 8 minus 7.8 is minus 0.2, and 7 minus 7.8 is minus 0.8, and the 6's minus 7.8 is negative 1.8, and the 5 minus 7.8 is negative 2.8. Then the next column over is that number squared. So we have parentheses x sub I minus the mean squared. So we have 2.2 squared is 4.84. 1.2 squared is like 12, is 1.44 squared is 1.44 for all those 4. 0.2, positive or negative, didn't matter, is 0.04 squared. Negative 0.8 squared is 0.64. The 3.24s come from the 1.8 squared, and the 2.8 squared is 7.84. Now we add all those in the last third column, and they all come to 25.6. So now that was the summation of I equals 1 to 10 of xi minus the mean, 7.8 squared, which is 25.6. Now the first number that we have a name for is that summation of 25.6 divided by how many numbers there were, 10. So 25.6 divided by 10 is called the variance, which has to do with the squares of the difference from the mean. This all has to do with how spread out the numbers are. And then we take the square root of the variance. Square root of 2.56 is 1.6. That's called the standard deviation. That's what we'll use in our next section to draw out our normal distributions. Now in this problem, we're going to find the first three quartiles of the sorted data, and quartiles are just like quarters. So as you can see, Q1 or quartile 1 is P25 or 25th percentile. It means that from that number, 25% are below it. And P2 is P50, or Q2 is P50, which is the 50% median. So Q2 and median mean exactly the same thing. And Q3 is the third quartile, just like money, 3/4, 75 cents, or 75% of the way through the data. So now we have the sorted data, 63, 68, 71, 73, 74, 75, 78, 81, 88, 92, 96. Now here we have an odd number of values, 11, so there is a middle, the sixth one, which is 75. So the way we can calculate that is when we have an odd number, we can do it this way. Looking at Q2 first, because that makes the most sense, 0.50 of 11 plus 1 is equal to the sixth item in the list, which is 75, the middle one. So if you'll see, there's 5 numbers below that, lower than that, and 5 numbers higher than that. But I don't have to go in between two. I can go to just one for an odd number of values. Now for the Q1, 25%, we take the median of the bottom 5, which is clearly the third one. But we can do it in formula by 0.25 times 11 plus 1, or 12, is the third in the list, which is 71. But that's the median, the middle of the bottom 5. And then we look at Q3 as the median of the top 5, which is clearly 88. Or in calculator, 0.75 times 12 is the ninth one in the list. Now, we are asked to calculate a thing called IQR, which is Q3 minus Q1, which is really the middle 50%, which is showing how the middle is spread out, which for us is 88 minus 71, or 17. Now we're going to draw a box plot, which includes the 5-number summary, which is the lowest number, the Q1, the Q2, the Q3, and the highest number. So seeing that our lowest number was 63, that's what I had the tail out for. And we saw that our Q1 was 71, that's where the box starts at Q1. The median was 75, so I put that on the scale in the middle between 70 and 80. And the end of the box is on 88. So the box Q1 to Q3 is the middle 50, with Q2 being the median. And the highest number we saw was 96, so that makes our box plot. Okay, now on example 4, we have 11 numbers, 1, 6, 7, 8, 8, 8, 9, 9, 9, 10, 10. And this is 11 numbers, so just like we did before, we can go to the sixth one and find the median, which is 8. 1, 2, 3, 4, 5, 6. The third 8 is the median. That's the sixth number of 11, the middle, 5 below, 5 above. The median of the bottom 5 is 7, and the median of the top 5 is the third 9. So that's the Q1, Q2, Q3. Now 1 is called an outlier because it's so far away from the pack. The rest of the pack is from 6 to 10, and 1 is way far away from that, which would drag the mean lower. Now the mean here is the summation of all the 11 terms divided by 11, which is 1 plus 6 plus 7 plus 3 eighths plus 3 nines plus 2 tens, which turns out to 85 over 11, or 7.7. Okay, now, and we can see again from above that Q2, the median, was 8, Q1 was 7, Q3 was 9. Okay, now just to show the difference of taking that 1 off, we subtract the 1 off and now have only 10 numbers for part B, which starts with 6, 7, 8, 8, 8, 9, 9, 9, 10, 10. Now with the 10 numbers, we have to go halfway in between the 5th and the 6th, or have a mean of 8.5. Okay, or median, rather, the median, the 50th percentile, the Q2 is 8.5. And the Q1 is 8, and the Q3 would be 9. It isn't circled there, but it is. So the mean is now the 10 of those numbers, 6 plus 7 plus 3 eighths plus 3 nines plus 2 tens is 84 over 10, or 8.4. Now notice it's higher than the one above, which had the 1, which we took out for this one. So that 1 pulled the mean lower from 8.4 to 7.7. Now, as we said, the median is 8.5, the Q1 is 8, the Q3 is 9, and the IQR, Q3 minus Q1, the middle 50% is real close. It's just got a 1. Okay, now the homework here starts on page 587. And again, we're given a list of 11 numbers which are on the first line, and the checks above them are me sorting them, which has to be done. So the first one's 8, which is about in the middle, then a 10 on the first, and then 11 about the third, and then 12, the second number, 14 is next to last, 15 is the fourth, 17 is 3 from the last, 18 is above the middle, 19 is below the middle, 20 is the last, and 21 is above the middle. So that's sorted, and we have 11 numbers. So again, we know we can go to the sixth one, which is 15 for my Q2. The third one is 11, Q1 is 11, 25 percentile, Q1, and Q3 is the 19, which is the median of the upper 5. That's Q3. Now for problem 4, we have to sort again. So we have a 33, and we have actually 3 33s, and those go first, and then the 38, which is the first from above, and then 43 in the middle, and then 47 the second, and 52 second from the last, and 56, which is somewhere, okay. And now it's in there. I did a misprint. It should have been 56 among the original top numbers. So we have 8 values, and so our median is between the 4th and the 5th. As you can see here, median is the 4th plus the 5th over 2, or where the bar is, 38 plus 43 over 2, or an artificial place, which should be 40.5, which would have 4 numbers below and 4 numbers above. Now Q1 is the mean of the bottom 4. Again, I'd have to average those. So that would be the second plus the third over 2, which is between 33, so it stays 33. And the median of the top 4 would be halfway between 47 and 52, the 6th and the 7th, or 49.5. Now here, the mean for this, which I skipped over, was 3 33s plus 38 plus 43 plus 47 plus 52 plus 56 divide 8, which is 335 divided by 8, or 41.875. And when we look at the mode, clearly the mode for problem 4 was 33, because there was 3 of them. Now 6 is where we're going to do a standard deviation again. So of the 8 above, we have them listed from low to high this time. So the 333s, the 38, the 43, 47, 52, 56, and the underlines are between the fourth and the fifth is the median. Under the second 33 is the Q1, and under the 47 is the Q3. Okay, the halfway points. So then again, we saw that our mean was 41.875. So we take 4133 minus 40.5. Okay, where did that come from? Yeah, so anyway, the mean is the number minus 40.5. So it's 33 minus 40.5. The first three are negative 7.5. 38 minus 40.5 is minus 2.5. 43 minus 40.5 is 2.5. 47 minus 40.5 is 6.5. 52 minus 40.5 is 11.5. And 56 minus 40.5 is 15.5. Now those numbers squared, the first three, negative 7.5 squared to 56.25, and negative 2.5 and 2.5 both squared to 6.25. 6.5 squares to 42.25, 11.5 squares to 132.25, 15.5 squares to 240.25, and if we add up those 8 numbers, we get 596. So the variance, again, is defined as the sum of those squared differences from the mean divided by how many are 8 of 596 over 8 is 74.5. The square root of 74.5 is 8.6, and the IQR is 49.5, halfway between 47 and 52, and minus 33, because the Q1 is between the two 33s. So the IQR is 16.5. And the range is the high minus low of 56, the highest one, minus 33, the lowest one. So that IQR looks like a misprint that I have on the sheet, so that's a mistake. So it should really be 49.5 minus 33 is not 7, but 16.5, okay? Now for problem 8, we have to sort the data again, but we're gonna have 10 numbers, and we have 2 6s are the smallest, then a 12, the second number above, 17 about in the middle, 18 the third, 19 in the middle, 19 again near the end, 21 at the end, 22 near the end, and 24 the fourth one. So sorting those with 10, we're halfway between the 5th and the 6th, or halfway in between 18 and 19, which is 18.5. And Q1 is the median of the bottom 5, which is the middle number 12. So the median of the bottom 5 values is 12, which is Q1, the 25th percentile. And Q3, the median of the 5 numbers above the middle median, is 21. And so then a box plot would show 6 being the lowest number, Q1 being 12, median being 18.5, Q3 being 21, Q1 to Q3 is the box, and that's the IQR of 16.5, and the high number is the one at the end, 24. So the 5-number summary, remember, is what we make the picture of the box plot from: the low, the Q1, the Q2, the Q3, and the high. And that's what we have pictured on the box plot. Okay, just one more of these sorts. Here's 9 numbers. The middle is the lowest, 44, and then 45 comes in about the middle. Then there's a 48 the first and a 48 the last. There's a 49 above the middle, a 59 after that, a 52 the second one, a 55 the second to last, and a 56 the third. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and with an odd number of values, I can go directly to the middle number, which is 49, the 5th number. So that has 4 numbers above and 4 numbers below. That makes it the median. Okay? And then the median of the bottom 4 is halfway in between 45 and 48, or do they ask for that? I guess they don't. Okay? But it would be 46.5, and the Q3 halfway between 52 and 55 would be 53.5. Now the mean is adding all the 9 numbers up, 44 plus 45 plus 2 times 48 plus 49 plus 51 plus 52 plus 55 plus 56 all over 9, or 448 over 9, which turns out to be 49.78. We've already defined the median, and the mode is 48 because it has a repeat of 2. Now the Q1, which I already said they're doing now, which is the second plus the third over 2, the median of the bottom 4, which is 45 plus 48 over 2, 46.5. The Q3 is the median of the top 4, halfway between 52 and 55, or 53.5. The IQR is 53.5 minus 46.5, or 7, the width of the box, and the high minus the low of the range is 56 minus 44, 12. Now finally we get an easy one. If the standard deviation, that's the symbol, Greek symbol for sigma, it's called that 0 with a little extension to the right, sigma, standard deviation equals 15, then sigma squared equals 15 squared, or 225. We all like those easy problems. Now 16, if the summation of x sub I equals 150, if adding them all up is 150, and the mean itself is 7.5, then 150 over n is 7.5, and cross multiplying, 7.5n equals 150. 150 over 7.5 gives us an n of 20 numbers that were added. Now for the last 2, I'm just copying the pictures that are from the book that are unemployment in 2009 and 2010, a box plot. So in 18, they're asking what was the highest unemployment figure in 2010. So we would look at that and look at the bottom little smaller picture, the box plot that's very compact, and take the high dot and go up to 9.9. And then they ask in 2009, what does that represent? That's the Q3 on the top widely extended box plot, the right side of the box. Now on 20, it says between what percentages did the middle 50% of the monthly unemployment fall in 2009, the big plot, the big spread out plot. So Q1 looks to be 8.9, and Q3, we already said, was 9.9. And that finishes our Thursday. God bless you. Hang in there. We're almost to Friday.